All right, welcome. We are going to finish up the notes for BC Calculus. I'm specifically going to finish up the 2.3 notes. We had one more example, and then we'll also do the 2.4 notes. So back on the 2.3 notes, example 5 that we didn't get to do last class. Let's say a particle moves in the xy plane, and its velocity vector, given in terms of t, is 3t squared minus 4t for the x component, and then 8t cubed plus 5 for the y component. We also know that when t is 0, so at the initial part of this particle moving as we track it, its position is 7, -4. Notice that that's an ordered pair. So these are xy coordinates. We want to find the position of the particle specifically at 1, and we don't want to use a calculator. Okay, we're not allowed to use a calculator. So keep in mind that the velocity is the rate of change of the motion. So see if this makes sense. If you want to find the position, let's use F as the position. Actually, what we'll do is we'll call X of t the X position. And let's call Y of t the Y position. Now we know that the position is starting in terms of the X. Let's just look at the X first. We're starting at a position of 7. And then we're moving. And remember, the velocity X component will show us the rate of change of that movement. So if I want to undo that movement, that would allow me to see how that X position is changing. So if I want to find the X position at a certain ending position, where B is like the ending time, what I could do is I could find the position at a starting time, which I actually have that. And I could add on to that the integral of the velocity component for X. And what happens here is if I undo with the integral, the velocity, and I over a definite integral, and I'll go from my starting to my ending position, this will tell me the change in the position. It'll undo the velocity to go back to position. And since I'm doing this over a definite integral, I would then be subtracting the positions, which will give me the change in position. So if I know where I'm starting, and I know how the position's changing, and I combine that, I can find out where I'm ending. So in this instance, if I want to find the X coordinate specifically at 1, if I know the X coordinate at 0, I can do the definite integral from 0 to 1 of the velocity component for X, which is 3t squared minus 4t dt. So the position at 1, I could take the starting position at 0, and I'm just looking specifically at X, so this is 7. And now I'm going to integrate this as t cubed. I'm just using the power rule, minus 2t squared. And I'll evaluate that at 1 and 0. So this is 7 plus, let's see, this would be 1 minus 2 minus 0. And so I would end up, this is supposed to be an equal sign, that the x coordinate here at the time of 1 would specifically be 6. Now, by the way, this formula here that I just showed you does have a name. This is called the accumulation formula. We'll talk about it a lot in AB. So here's a little preview for you. Well, maybe pause the video, see if you can use the accumulation formula for Y. And I'm going to walk through that for those of you who'd like to see that. So if I want to find the accumulation for Y at a certain point, find out where an ending location is, I could take the starting location for Y and then do the integral at the starting and ending time as my limits of the change in Y. Okay, so the rate of change in Y, or the velocity. So for this instance, if I want to find Y at 1 and I know what Y at 0 is, I can add on to that the integral from 0 to 1 of the derivative of Y, which we know that the derivative of the position is the velocity. So they gave us that component with 8t cubed plus 5, and then we'll take that integral with respect to t. So Y of 0 is -4, and then if I use the power rule here, I'd get 2y to the 4th plus 5t, and I want to evaluate that at 1 and 0. So -4 plus 2 plus 5 minus 0 would end up with an ending y value at time 1 of 3. And then we want the position. Position is always implying an ordered pair of x, y. So we want to write this as the x coordinate and then the y coordinate. And since this is an ordered point, notice we have regular parentheses. So that's the end of the 2.3 notes. Moving on to 2.4, we can use a calculator on these examples. But we do want to be careful about